Have you ever wondered what lies beneath your feet? The Earth's crust floats atop a sea of molten rock called magma. Sometimes this magma bursts through, creating volcanoes. But not all volcanoes are the same. Mega-volcanoes or super-volcanoes are hidden giants with the power to reshape the world. Unlike the classic cone-shaped volcano, these giants often appear as vast, beautiful landscapes, calm on the surface, but holding immense power below. Their eruptions have changed the course of Earth's history, affecting life and climate on a global scale. Thankfully, mega-volcanoes are rare, with thousands of years between eruptions. This gives us time to study and prepare, turning fear into knowledge. Scientists are like detectives, searching for clues to understand these mysterious forces. By learning about them, we can appreciate the dynamic nature of our planet. Our journey will take us to Yellowstone, Toba, and Campi Flegrei, places where the Earth's power is both a threat and a wonder. We'll discover what makes these volcanoes unique and how scientists work to keep us safe. This is a story of power, science, and human curiosity. Let's explore the hidden giants beneath us and the incredible forces that shape our world. Join us as we uncover the secrets of the sleeping giants. The adventure begins now. Not all volcanoes are created equal. While classic volcanoes like Mount Fuji are tall and dramatic, mega-volcanoes are defined by the scale of their eruptions, not their height. Scientists use the Volcanic Explosivity Index, or VEI, to measure eruption size. Regular eruptions might reach VEI 2 or 3, but only megavolcanoes hit VEI 8, the most explosive on Earth. The secret lies in their massive underground magma chambers, stretching for miles and storing unimaginable amounts of molten rock and gas. Over thousands of years, pressure builds until the crust can't hold it anymore, resulting in an eruption of staggering force. Instead of forming mountains, these eruptions collapse the ground, creating enormous calderas, giant bowl-shaped depressions that can span dozens of miles. Many megavolcanoes are so vast, you might not even realize you're standing inside one. Yellowstone, for example, is a beautiful park sitting atop a colossal ancient caldera. The magma in megavolcanoes is thick and gas-rich, making eruptions extremely explosive. When they erupt, they blast ash, rock, and gas high into the atmosphere, spreading material across continents. A single VEI 8 eruption can release over 1,000 cubic kilometers of ash, enough to blanket entire countries. This is what sets megavolcanoes apart. Their eruptions are rare, but when they happen, they change the world. Scientists study these giants to understand their power and to prepare for the future. The scale of a megavolcano is almost unimaginable, but understanding them is key to our safety. These are not just geological curiosities, they are forces that have shaped and could reshape our planet. The next time you see a wide, peaceful valley, remember, it might be the scar of a sleeping giant. Megavolcanoes are rare, but their impact is global. That's why they fascinate scientists and inspire awe in us all. Our first stop is Yellowstone, a world-famous megavolcano in Wyoming. The park's geysers and hot springs are surface clues to the vast magma chamber below. Yellowstone's caldera, about 30 by 45 miles wide, was formed by a super-eruption 631,000 years ago, 1,000 times bigger than Mount St. Helens. This hotspot has triggered at least 3 massive eruptions in the past 2 million years. If Yellowstone erupted today, the immediate area would be devastated, and ash would blanket much of North America, disrupting life far beyond the blast zone. The global climate could cool for years, causing crop failures and food shortages. But the odds of a super-eruption soon are extremely low, about 1 in 730,000 each year. Yellowstone is one of the most closely monitored volcanoes on Earth, with scientists tracking every tremor and gas emission. While a massive eruption is unlikely, constant vigilance ensures we're prepared for any changes. Yellowstone is a reminder of the power beneath our feet, and the importance of science in keeping us safe. Next, we travel to Lake Toba in Sumatra, Indonesia, the site of the largest eruption in the last 2.5 million years. The peaceful lake fills a caldera left by a VEI 8 super-eruption 74,000 years ago, which blasted out nearly 2,800 cubic kilometers of ash, 3 times more than Yellowstone's last eruption. Ash from Toba spread across continents, and some scientists believe it triggered a volcanic winter lasting up to a decade. This event may have pushed early humans to the brink of extinction, showing how a single eruption can alter the course of history. Today, Toba is a tourist destination, but the volcano remains active and closely monitored. The island of Samosir in the lake is actually a resurgent dome, land pushed up by magma after the eruption. Studying Toba helps scientists model the global effects of super-eruptions and prepare for the future. While another eruption is unlikely soon, Toba's story is a powerful reminder of Earth's potential for sudden, dramatic change. Understanding Toba is key to understanding our own survival. Our final stop is Campi Flegrei, near Naples, Italy, one of the world's most dangerous mega-volcanoes because of its location. Over 1.5 million people live on or near this active caldera, making it a high-risk area. Campi Flegrei's biggest eruption, 39,000 years ago, spread ash across Europe and Asia. The caldera we see today formed after a major eruption 15,000 years ago, and the volcano has had smaller eruptions since. The ground here rises and falls, a phenomenon called bradycism, signaling magma movement below. In the 1980s, ground uplift forced thousands to evacuate, and the area is rising again today. Scientists monitor Campi Flegrei closely, with detailed emergency plans and alert systems in place. The challenge: how to evacuate hundreds of thousands if danger looms. Campi Flegrei is a real-world test of science, planning, and public safety. It shows the importance of combining research with community preparedness. Living with sleeping giants means staying alert and ready. A super-eruption would be catastrophic, starting with devastation near the volcano, pyroclastic flows and thick ash burying everything in their path. Ash would collapse roofs, contaminate water, destroy farmland, and cause severe respiratory problems. Transportation would halt as engines clog and air travel becomes impossible. The biggest impact, though, would be global sulfur dioxide in the stratosphere would block sunlight, causing a volcanic winter. Temperatures would drop, growing seasons would shrink, and food shortages could trigger a worldwide crisis. International trade and travel would be disrupted, and social instability could follow. This is why scientists and governments plan for even the rarest events. Understanding the chain reaction of a super-eruption helps us prepare, stockpiling food, strengthening infrastructure, and coordinating global responses. The effects would touch everyone, everywhere. Preparation is our best defense against the unimaginable. By studying megavolcanoes, we're not just learning about the past, we're protecting our future. The stakes are global, and so is the responsibility. How do we know if a sleeping giant is waking up? Volcanologists use cutting-edge tools to monitor every sign of change. They track ground deformation with GPS and satellites, watching for swelling as magma rises. Seismometers detect earthquake swarms, signals of magma moving underground. Gas emissions are measured from vents and even by drones. Spikes in sulfur dioxide or carbon dioxide can mean magma is nearing the surface. By combining these clues, scientists build a real-time picture of a volcano's health. They also study past eruptions to predict future behavior. This constant monitoring is our best early warning system. While we can't predict the exact moment of eruption, we can spot the warning signs and act in time. Early detection gives authorities precious time to prepare and save lives. Science is our first line of defense against the giants below. Detecting danger is just the start. Preparation is critical. For those near active calderas, clear evacuation plans and public education save lives. Governments build resilience by stockpiling food, protecting infrastructure, and supporting farmers. International cooperation is essential. No country can face a super-eruption alone. Organizations like the UN help coordinate global responses, share data, and manage aid. Scientists worldwide collaborate to improve monitoring and hazard planning. Everyone can prepare. Keep an emergency kit, stay informed, and know your local risks. Preparedness turns anxiety into action and builds resilient communities. By working together, we can face even the greatest natural threats. Our safety depends on science, planning, and global teamwork. Mega-volcanoes remind us of nature's power, but also of our own ingenuity. We can't stop a super-eruption, but we can learn, innovate, and prepare. Scientists are making breakthroughs in monitoring and understanding these giants every day. Their work gives us time to act and keeps us safer than ever before. Emergency plans and global cooperation are the result of decades of research and dedication. Studying megavolcanoes also reveals Earth's history and inspires awe for our dynamic planet. We are the first generation able to watch these giants in real time. By respecting their power and advancing our science, we build a safer future. The story of megavolcanoes is one of discovery, resilience, and hope. Let's continue to explore, prepare, and protect our world together. The sleeping giants beneath us are part of our story, and with knowledge, we can live with them wisely. The adventure of understanding our planet never ends.